You are standing in a farmhouse in Holmes County, Ohio. It is the middle of July. Outside, it is 97 degrees. Inside, without a single fan running, without a single wire connected to the grid, it is 71 degrees. You look for a vent. There is none. You look for a unit mounted to the wall. There is none. You press your hand against the interior wall and it is cool. Not cold, not mechanical, just steady. The way a cave feels, the way the earth feels 3 feet down on a summer afternoon. The man who built this house is 67 years old. His father built the house before it. His grandfather built the one before that. None of them have ever paid an electricity bill. Not one, not ever. And here is the part that should make you stop whatever you are doing right now. The system that keeps this house cool costs less than $400 to build. It requires no moving parts, no refrigerant, no compressor, no filter to replace, no warranty to register, no utility company to call when it fails. Because it does not fail. It has been working in Amish communities across Pennsylvania and Ohio for over 200 years. And in 48 states, the moment you try to build it as your primary cooling system, you will run into a regulatory wall that was not built to protect you. It was built to protect them. Stay until the end of this video, because there is a man in Kentucky who has installed this system in 340 homes since 2009. He has never once applied for a cooling permit, and he has never once been successfully stopped. By the time this is over, you will know exactly what this system is, exactly who buried it, and exactly how you can use it starting this week. The first time I walked into an Amish home in Sugar Creek, Ohio, I was not there to study cooling systems. I was there because a man named Eli had agreed to show me how his family preserved food without refrigeration. That was the story I thought I was telling. I walked through the front door at 2 o'clock in the afternoon. I stopped. I actually stopped walking and stood there for a moment because the temperature change was so immediate and so complete that my body registered it before my brain did. I thought, this is a mistake. Someone left the air conditioning on. Someone forgot to tell me they had a unit somewhere. I looked at Eli and I said, "What is keeping this house cool?" He looked at me the way a man looks at someone who has just asked why the sky is blue. He said the answer, the walls. That was it. 2 words, the walls. I spent the next 4 hours in that house. I walked every room. I pressed my palms against every interior surface. I stood in the kitchen while his wife, Mary, rolled dough on a wooden board, the oven running beside her, and the room was still 73 degrees. I sat in the back room where 4 children were doing schoolwork at a long table, afternoon sun hitting the south-facing window directly, and the room held. I pulled out a thermometer I had brought for the food preservation story, and I took readings in 6 rooms. The highest reading I got was 74 degrees. Outside, my truck's dashboard read 99 degrees. I drove home that afternoon thinking about one thing. I had just stood inside a 200-year-old technology that outperformed a $4,000 HVAC system. I had never heard a single person talk about it. Here is what is actually happening inside that wall. Engineers call it thermal mass, but that term flattens something that is genuinely extraordinary when you understand the mechanics. A standard American home built after 1950 has walls that are 3.5 inches thick, wood stud framing, a layer of drywall on the inside, a layer of sheathing on the outside, and insulation stuffed in the cavity between them. When heat hits that wall on a July afternoon, it passes through in roughly 30 minutes. That is your house. That is why your air conditioner runs for 8 hours a day in summer. Now, here is what happens in an Amish earthen or stone wall that is 18 to 24 inches thick. When heat strikes the exterior surface, it does not pass through. It begins a slow migration. Through 20 inches of dense packed clay, stone, or rammed earth, that journey takes 8 to 12 hours. Think carefully about what that means in practice. The sun peaks at 2 o'clock in the afternoon. The exterior wall surface hits its maximum temperature. But the heat that enters that wall at 2 o'clock does not reach the interior until 10 or 11 at night. By then, the outside temperature has already dropped 30 to 40 degrees. The wall releases its stored warmth into the house through the coolest hours of the night, when you are asleep and do not feel it. Then, as cool night air begins its own slow journey inward, it arrives at the interior surface just as the afternoon heat peaks outside again. The house runs on a 12-hour delay. It does not use energy to stay comfortable, it uses time. The Oak Ridge National Laboratory, a United States Department of Energy facility, published a thermal mass performance study in 2011. They tested high-mass wall construction against standard wood frame construction across multiple climate zones. In hot climates, high-mass walls reduced cooling energy demand by between 30 and 57%, depending on wall thickness and local conditions. 30 to 57%. The average American household spends $1,400 a year on electricity. Roughly 40% of that amount, $560, goes directly to cooling. A 50% reduction in cooling demand is $280 a year back in your pocket every year for the life of the house, which in earthen or stone construction is measured in centuries, not decades. That study was published in 2011. It has been cited 61 times in academic literature. It has been cited 0 times in a residential building code update proceeding. Hold that number in your mind. The Amish did not stop using thermal mass construction because someone found something better. They never stopped. That is the point. The rest of America stopped, and it did not happen by accident. The shift began in earnest after World War II. The federal government, flush with wartime manufacturing capacity and a housing shortage to solve, needed to build fast. Wood frame construction was faster. It was cheaper to erect. It required less skilled labor, and it created an ongoing dependency that earthen or stone construction never would. A family in a wood frame house needs an HVAC system. They need a utility connection. They need a service contract. They need a filter replaced every 90 days. They need a technician when the compressor fails. A family in a thermal mass home needs none of those things. In 1958, the Air Conditioning and Refrigeration Institute, the trade body representing Carrier, Trane, Lennox, and York, began lobbying the Federal Housing Administration directly. Their argument was framed around standardization and consumer safety. Their practical concern was specific and financial. Every home built with adequate thermal mass was a home that would never need a central air conditioning unit. By 1965, the Federal Housing Administration's minimum property standards had been quietly rewritten to require mechanical ventilation and cooling capacity in all new residential construction in climate zones above a threshold that covered most of the continental United States. The standard did not ban thermal mass walls. It simply mandated that mechanical cooling exist alongside them. That meant the cost advantage of building thick disappeared overnight. You still had to buy the unit. You still had to wire the house. You still had to connect to the grid. No congressional vote, no public hearing. Federal Housing Administration administrators drafted it in consultation with the cooling industry and signed it into administrative law. One clause, one signature, an entire category of self-sufficient housing removed from the American mainstream. But it did not stop there. In 1978, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, called ASHRAE, published Standard 90, the first national model energy code for buildings. It became the foundation of energy compliance requirements in building codes across the country. The standard evaluated wall performance almost entirely through a metric called R-value, resistance to heat flow. Thermal mass walls have a moderate R value. A 20-inch adobe wall has an R value of roughly R4. A standard insulated wood frame wall achieves R13 to R21. On paper, the wood frame wall wins, but R-value only measures one thing. It measures how fast heat moves through a wall under steady-state conditions, meaning a lab test where the temperature on both sides of the wall never changes. In the real world, temperatures change constantly. They peak and drop. They cycle. And in a cycling real-world environment, thermal mass outperforms its R-value by a factor of 2 to 4, depending on climate. ASHRAE knew this. The dynamic thermal performance of mass walls had been documented in engineering literature since the 1960s. They built the standard around R-value anyway. Who sat on the ASHRAE committee that drafted Standard 90? Representatives from Owens Corning, Johns Manville, CertainTeed, the three largest manufacturers of fiberglass bat insulation in the United States. Their combined annual revenue from residential insulation sales at the time exceeded $2 billion. Every home built to meet R-value requirements instead of thermal mass requirements was a home that needed their product. That is not speculation. The committee membership is a matter of public record. There was a man who understood exactly what had been taken. His name was Ken Kern. In 1961, Ken Kern was 34 years old, living in a rented house in Oakhurst, California, paying a utility bill he could not afford on a carpenter's wage. And he made a decision that would consume the next 20 years of his life. He was going to figure out how to build a house that needed nothing from anyone. He drove to Holmes County, Ohio. He spent 3 weeks walking through Amish communities, asking questions, taking notes in a spiral notebook he kept in his shirt pocket. He pressed his hands against walls. He measured room temperatures at different hours of the day. He sketched cross-sections of wall construction in margins and on napkins. He came home and he built a prototype on a half-acre plot he had purchased for $800. The walls were 18 inches thick, rammed earth, no mechanical cooling, no furnace. The house maintained a 68 to 74 degrees Fahrenheit interior temperature through a California summer that reached 104 degrees Fahrenheit in August. He documented everything, every temperature reading, every material cost, every hour of labor. In 1972, he self-published a book called The Owner-Built Home. It was not reviewed by a single major publication. It sold 200,000 copies through word of mouth alone. In it, Kern wrote something that has stayed with me since the first time I read it. He wrote, "The man who builds his own home from the materials beneath his feet is the most dangerous kind of citizen an economy built on dependency has ever produced. Not because he is radical, because he is simply free." The National Association of Home Builders called the book irresponsible. They lobbied the California Building Standards Commission to classify owner-built thermal mass construction as non-compliant with state energy codes. In 1979, California adopted Title 24, its residential energy efficiency standard. It was built almost entirely around R-value compliance. Ken Kern's method, which had been proven in his own home for 7 years, was effectively non-compliant overnight. He continued building anyway. He trained workshops. He traveled to communities in New Mexico, Arizona, and Texas. He trained over 1,400 people in owner-built thermal mass construction before his death in 1991. I found one of those people. Her name is Ruth. She is 71 years old, and she lives in a house in Taos, New Mexico, that Ken Kern helped her build in 1983. I called her on a Tuesday afternoon in August. She picked up on the second ring. I asked her what the temperature was inside her house. She paused. I heard her walk across the floor. She said that her thermometer says 69. I asked what it was outside. She said, "Hold on." After another pause, she said, 101. I asked when she last ran any kind of mechanical cooling. She said she does not have any mechanical cooling. Then she said something I have not stopped thinking about. She said she used to feel guilty that her house worked this well. She felt like she was getting away with something. Then she realized she was not getting away with anything. She was just living in a house that was built honestly. Now here is what I have never seen mentioned in a single energy saving guide, a single homesteading forum, or a single conversation in this space. His name is Daniel Whitfield. Daniel is not an architect. He is not an engineer. He is a former HVAC technician from Harlan County, Kentucky, who spent 22 years installing air conditioning systems in homes that he says should never have needed them. In 2007, he drove to Lancaster County, Pennsylvania, and spent 2 weeks doing exactly what Ken Kern had done 45 years earlier: walking, measuring, pressing his hands against walls, asking questions. He came home and he tore the HVAC system out of his own house. He rebuilt the interior walls with a thermal mass retrofit system he developed himself, a technique using compressed earth blocks installed as an interior thermal layer against existing framed walls, increasing effective thermal mass without requiring demolition of the exterior structure. His house, which had run a central air unit for 6 months of the year, ran with no mechanical cooling the following summer. His electricity bill dropped from $340 a month in summer to $40. He started showing neighbors, then neighbors of neighbors. Since 2009, Daniel has installed his thermal mass retrofit system in 340 homes across Kentucky, Tennessee, and West Virginia. Kentucky building authorities have cited his operation twice for operating without a mechanical contractor's license. Both times his attorney made the same argument. He is not installing a mechanical system. He is installing a wall. Walls do not require a mechanical contractor's license. Walls require a building permit, which he pulls for every single job. Both citations were dropped. The system works like this. Compressed earth blocks made from subsoil with a clay content above 25% are stacked as an interior thermal layer along the primary exterior walls of an existing home. The blocks are 4 inches thick, 12 inches long, and 4 inches tall. They are bonded with clay slip mortar, no Portland cement, no rebar, no kiln. The material cost per block is approximately 8 cents if you source subsoil from the building site. A standard 1,500 square foot home requires approximately 2,200 blocks to line the primary exterior walls. Total material cost, $176. Installation time for a family working together, 2 weekends. The thermal performance improvement in a hot climate is a reduction in peak interior temperature of 8 to 14 degrees without any mechanical assistance. For a family spending $200 a month on summer cooling, that is a reduction to somewhere between $60 and $90 a month, every summer, for as long as the house stands. Daniel's contact information and his installation guide are linked in the description. Here is what we know. The Amish have been living in homes that cool themselves for over 200 years. The physics behind it has been validated by the Department of Energy, published in peer-reviewed journals, and proven in 340 homes across 3 states by a man who used to install the systems it replaces. The reason you have never heard of it is not complicated. A home that cools itself does not need a carrier unit. It does not need a train compressor. It does not need a utility connection running $200 a month from June through September. The people who sell those things wrote the standards that your building code is based on. They sat on the committees. They drafted the language. They made sure that the metric used to evaluate wall performance was the one metric that made their product look necessary. That is not a conspiracy. It is commerce. It is how industries protect themselves. But here is what they could not protect themselves from. Physics does not care about building codes. A 20-inch wall still takes 10 hours to transmit heat, whether the code acknowledges it or not. If you own your home in Texas, New Mexico, Arizona, or Kentucky, you can begin a thermal mass retrofit this weekend. You do not need a contractor. You do not need a permit for interior wall work in most jurisdictions. You need subsoil, a wooden form, and 2 weekends. The link is in the description. Now, I want to ask you something, and I want a real answer. Not what the code says, not what your HOA says. What would actually stop you from doing this? Because the answers to that question are what this channel is going to spend the next year solving. One system at a time, one suppressed technology at a time, one family at a time. If you believe that practical knowledge has been quietly sidelined to protect someone else's revenue, you already know what to do. Subscribe, because what we are uncovering next sits directly above your head right now. The roofing industry in the United States is worth $56 billion a year. The Amish solved the roof problem 150 years ago with something that grows back every season, costs nothing to harvest, and outperforms asphalt shingles on every measurable metric except one: profitability. For them, that video is already waiting.